Welcome to today's lesson on rational functions. Topic 1 is focused on vertical and horizontal lines. A vertical line will always have an x equals equation. And you can see written in blue, I have a reference to each vertical line. When you graph a vertical line, which I'm going to put up here on the top left, the first example of x equaling 1 would be 1 to the right. This vertical line is the line whose equation is x equaling 1. If it's x equaling negative 10, it would be far to the left side at x equaling negative 10. If it's x equaling 1/2, it would be halfway to the right of the origin. Now note that every vertical line has an x-intercept, which is this point where it crosses the x-axis. So x equaling 1 has an x-intercept at 1, 0. So this would be, I have this done incorrectly, this would be in blue 1, 0 as its x-intercept. For the x equaling negative 10, this point would be the point negative 10, 0 as its x-intercept. So you can see your x equals lines have x-intercepts, which are your vertical lines. Your horizontal lines would be in green on this graph I'm drawing in the top right corner. If we have y equaling negative 4, it would be a horizontal line. And your other example would be y equaling 7, still a horizontal line. Notice these lines do not cross the x-axis, so they will not have an x-intercept, but they do have y-intercepts. Y equaling negative 4 crosses the y-axis at the point 0, negative 4, which is its y-intercept. Y equaling 7 crosses the y-axis at the point 0, 7, which is its y-intercept. So that should give you a pretty self-explanatory view of these horizontal and vertical lines. Topic 2 talks about rational expressions, which are fractions. And we need to remember that a fraction cannot have a 0 in the denominator. This makes the fraction undefined. So often we will write 0 under, meaning under the fraction, is undefined. So a memorization technique is the under is undefined. In topic 2, it wants to know which x values will make these rationals undefined. Your focus is in the bottom of the fraction only. So on number 12, if x equaled 7, this would be 7 minus 7, or a 0 in the bottom of the fraction. So you do not want the number 7 in that rational expression. Number 13 may be a little more difficult to just determine using mental math or pondering it just in your mind to try to come up with the x values that make that polynomial equal to 0. So in this case, we would algebraically write this equal to 0. Then we would factor it and set each factor equal to 0 to determine what values you cannot substitute into this fraction, because these values would make the fraction undefined. Now moving to the next page, Topic 3 says to solve. Now remember, when you solve, your answer is to find the x values that make the equation a true statement. The easiest way to work these examples would really be to cross multiply. And we cross multiply when we have a proportion, something like x over 2 equaling, say, 4 over 9, a fraction equaling a fraction. It's in these cases that we cross multiply. So looking at number 17, it is not a fraction equaling a fraction, but we can make this the case by adding 3 to each side. Then we would result in 1 over x minus 4 equaling 3, or 3 over 1. At this point, we can cross multiply and have 3 times x minus 4 equaling the 1 times 1. Now the solving process would be to distribute the 3, then to add 12 to each side, and then to divide by the 3. This is the solution to the equation. Another example would be like number 19. Again, we want a proportion. We want one fraction equal to one fraction. So let's actually move the 1 over x squared over, which would make it positive. Then we would have a fraction equal to a fraction, and when we cross multiply, we would get 4x squared equal to 1. Now we would use the square root property by dividing both sides by 4, and then taking the square root, resulting in two solutions, positive 1/2 and negative 1/2. Moving to the next page, we now are talking about vertical and horizontal shifts of a function, which are transformations. So they're transforming two graphs, y equaling 1 over x and then y equaling 1 over x squared. Remember, y equaling 1 over x is the graph that has two asymptotes. Looking at number 21, this is a transformation with the parent function being y equaling 1 over x. The minus 5 means that we move the graph to the right 5 units, and the minus 3 means we move down 3 units. So if I were to sketch this one, visualize the origin moving to the right 5 and down 3, and this would be the center point of your two asymptotes in your graph with these transformations would be sketched as I did just then. Looking at the y equaling 1 over x squared, this graph also has two asymptotes, and its graph would be in the upper two quadrants. So 25 will transform that graph. The x minus 3 would mean to go right 3, and the plus 2 would be up 2. Now the reason I know this is a transformation of the parent graph 1 over x squared is based on the squared on the binomial in this denominator. Now if I were to graph this, again I would focus on the origin moving to the right 3 and then up 2. This would give me my two asymptotes, and then my graph would be in the upper two quadrants of the two asymptotes. Connecting this to college algebra, this example 1, all you would need to do is start with the parent graph of 1 over x, and the subtraction of 2 would mean to go right 2 units. This next page is quite interesting. It gives us a graph, and it gives us the asymptotes occurring at y equaling -1 for the horizontal asymptote, and the vertical asymptote is occurring at x equaling -3. Noting the origin is over here. So you can tell this is the original parent function 1 over x, which has obviously been shifted to the left 3 and down 1. Part A says, as x approaches -infinity, which is the left side of the graph, y is approaching something. Well, remember, f of x is the y value. So as we're on the left side, as we're approaching or moving left, the y value is approaching the horizontal asymptote of -1. In part B, it states x is approaching positive infinity, which is the right side of the graph, which I will highlight over here. And again, the graph is approaching that horizontal asymptote of a y value of -1. Therefore, f of x or y is approaching -1 also on the right side. Part C says, as x is approaching -3 from the left, that little negative kind of exponent means from the left. So x is approaching -3, coming in from the left side would be, let's see if I can highlight it. X approaching -3 from the left side is here, which I've highlighted in the dark orange. And when we highlight that area, the y value is going up. So f of x is approaching positive infinity. Part D, as x approaches -3 from the right side, and let me highlight that region, which would be here, the right side of the vertical asymptote, it is going down, so the f of x, which is your y value, is going down to -infinity. That's a little more difficult a question, and if you can understand that, that is wonderful. This is the end of this recording, and thank you for staying to the end.